You, what's up, dudes? Hey, here we go. 4-4 coming at you. Hope you guys are doing great today. We're gonna kind of switch gears. So 4-1-2-3. We did all kinds of writing and stuff like that. We learned some new forms. Blah 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 blah. Okay. 4-4, 4-5. Good news. We are skipping 4-5. Correlation and causation. Easy stuff. Nobody cares about it. So we're gonna go 4-4 to 4-6. All on these little boppers right here. Maybe you've seen them, maybe you haven't, right? We're getting into a little bit of a statistics section on graphs, okay? It is uber amounts of fun. Lots of new words. Bivariate data, okay? This just means two variable data, okay? Those two variables, what are they going to be? What are they going to be? That's right, x and y. Those are our two variables. Okay, but typically they could be represented by like the height of a human and their arm span. Those could be your two variables, right? And then we're gonna compare them, right? The temperature. Ooh, it's the end of the day. I'm out of here. See you guys later. I'm just kidding. I'm back. Okay. Our two variables could be like, hey, temperature and like outside temperature and ice cream sold, right? Who knows? Anyway. Bivariate data, two things. Scatter plots, right? This is what we're looking at. Our scatter plots, guys, they're going to look like this. We're only focused on quadrant one, and literally, it's going to be dots. Okay? So it is you can't even see that very well. It is just a collection of dots in quadrant one. Simple definition. A collection of dots in quadrant one that represent two variables. All right, these next two mean the same thing. Correlation, association, right? Correlation, association, right? We have three types of correlation or association. I know, you want to know what they are, don't you? Okay. Type number one, positive. Type number two, you guessed it, negative. Type 3, none, okay? You can think about slope for these two, okay? So if we have positive correlation, things are going to be kind of like going uphill when we read it like a book, left to right, okay? If it has negative correlation or negative association, it will be going downhill, again, just like negative slope does when we read it like a book from left to right. Or there might not be any correlation or association, okay? All right, the last two, line of fit. Line of fit is a line we are going to hand draw on our graph. Once I have it drawn, I will then write an equation for that line. Ooh, lots of fun. This is where 4-1, 4-2, and 4-3 come into play, all right? We've been writing equations about certain points, okay? Linear interpolation. This is where we are going to predict values from within our range of data, right? Remember the book problem we had the other day, linear extrapolation, where we predicted the price of a textbook like in the future, right? The future hasn't happened yet, so we don't know what price it's going to be. Okay, this is the exact opposite. Here we're predicting, we're going to predict values from within our data, okay? Seems kind of weird because like we should already know what it should be, but it'll all make sense here soon, okay? There we go. A lot of new words in 4-4. Hopefully they're less confusing in about 20 minutes when we're done with this. All right, here's a much better view of scatter plots, my friends. So again, a collection of dots, right? These are all in quadrant one. If we're going uphill, just like we are here, right? This is positive correlation. Correlation, also what other word we just learned? Association. Oh, good job. Somebody said it. Good work. Association, okay? They mean the same thing. Positive correlation. Negative correlation. Again, we talked about slope, right? These lines going downhill, right? And then we got dots everywhere. If we have dots everywhere, there is no pattern to them, right? Think pattern. What are my dots doing? Oh, my dots are going uphill. Oh, dots are going downhill. Whoa, Dots everywhere, okay? So no correlation. I'm sure you can rewind that and watch me going everywhere again. It's pretty much sweet. Okay, anyway, onward we go. So we're going to do some super, super, super easy stuff, right, in 4-4, and then we're going to do some super annoying stuff. Here's some of the super easy stuff. It gives me a graph over here. Awesome. Okay. It just says determine whether the graph has positive, negative, or no correlation. Okay. So are the dots, or the majority of the dots going uphill, downhill, or just all over the place? On this one, I would say they're mostly going downhill. So downhill means negative, right? So I would say negative correlation or negative association here. Describe the meaning in the situation. Ooh. Okay, so think about it, guys. So I'm just going to zoom in on the graph. Come here, graph. Beautiful. All right, so here we go, guys. So these lines, right, they're all kind of going in that general fashion there. Well, what does that mean? Well, that means as our x values increase, right, because look, the x values are increasing as we go across here. What is happening to my y values? Again, we read graphs like a book from left to right. So my y values started up here, and they ended down here, right? So my y values were decreasing, okay? So let's interpret that in words. So as the years increase, right, the number of students per computer is decreasing, okay? That's how we would say that. Again, if you're not sure, guys, just use whatever quantities we have on our two x and y axis, right? Talk about it that way. Okay, alrighty. The best part of this is that I know that I have an audience, because I know some of you guys are watching these at home, and that's just great for me. Really excited. Good to see all of you anyway. Okay, same thing here, guys. Determine positive, negative, or none. Look at the graph. What do you think? What do you think? Well, you can't see the graph. There it is. Positive, negative, or none. Positive. That's right. Somebody said positive. We're going uphill here. Yes, absolutely. Positive. We see the breakdown here. We're going to see these all the time. Remember, that just means there is no data below this dot right here on the x-axis. Or I'm sorry, y-axis. Excuse me. Okay? What is the meaning of it? Well, again, positive means just the opposite. Same thing's going on with my x values. My x values are increasing. But this time, my y values, right? Here, these are all going uphill. Okay? My y values, not decreasing, my y values started here, right, almost at 90, and they end up all the way over here, about 145, all right? So x values increase, y values increase. Put it into words, people. As the years increase, the number of prescriptions increases. Okay? Awesome. Look, I'm excited. Look, we're over halfway through. Okay. All right, so that's the easy stuff. Here comes the annoying stuff. When we have to make scatter plots. Now, luckily, we'll show you, not today, but probably next one, in the next episode, called 4-6. We'll show you how to make scatter plots on Desmos. That'll be great. For now, we would make a scatter plot. Again, they're just a collection of ordered pairs, right? You all are very good at saying, okay, yep, this is the ordered pair, 10, 22, put a dot there. Okay, here's 8, 34, put a dot here, okay? So if we have to make a scatter plot, that's just what we're going to do. They're going to give us the data, don't worry. Then we're going to do this part, right? And this is what we call our line of best fit. And we will really get into this in 4-6. But it says draw lines that seems to pass close to most of the data points. Now, it's a good line. If our data points have positive association, right, then our line that we're going to draw, our line of best fit, should also have positive association. If our scatter plot has negative association, right, so going downhill, then our line of best fit better be negative too. Okay? Then step 3, we've done step 3 because that's all we've been doing in 4, 1, 2, and 3. Use 2 points on that line to write an equation. And then step 4 says use the line to make predictions. Okay, and we've kind of done this before, right? Like when we write a function and then we say, hey, okay, now that you figured out this, like how much does it cost for 4 lessons, right? I think that was one of our homework questions. We wrote that function, and then okay, 4 lessons cost this much money. That's the same thing we're doing here. We're just making predictions based off of that line. I know you're excited. You want to see this in action. Guess what? We'll show it to you right now. Okay, make a scatter plot. Here we go. Well, let me back up. Table shows the growth of the world population. Identify the independent and dependent variables. Ooh, y depends on x. Make a scatter plot. Determine what relationship, if any, exists in the data. Who's to say? Maybe there's a relationship. Maybe there isn't. I don't really know. Okay? Again, here is our years. Here is our population. Does the year depend on the population? No. The population depends on the year. So population, dependent variable, y. Year, independent variable, x. All right? So now we know x, y. Step 2 says draw a line of fit. Okay, did they give us a scatter plot for this? Did they give me a... No, they did not. You got to be kidding me. Okay. All right, so I'm going to have to make some room here. So you guys got to bear with me. Look, I'm going to make this go away. Nothing to see here, folks. Nothing to see here. So I'm going to give you just a real quick sketch of this scatter plot, and then we'll be more specific on the next one, okay? I appreciate how easygoing you folks are. Again, I'm only concerned with quadrant 1, right? This is population, and this is year, okay? So remember, get out of here. There you go. 1, 2, 3, 4, 5. I should have 5 dots on my scatter plot here, okay? Look, 1650, 1850, 19. Look, I don't really care how you do this, right? If you want to have a little break here, and then, all right, yep, here's 1650, and here's 1950, right? I'm sorry, that should be an 18. Whoa. Oh, no. 1850. Look what we've done. Goodness gracious. Okay. Anyway, you can fast forward and watch me do those. 1850, and here's maybe 1930, and here's 1975, and here's 2004. I hope your scatter plot is not nearly as messy as mine. Right? And then here we go. So I'm just going to assume that this is the 0.500, right, million. And then here it's double. Maybe this is 1,000 million, which is just a billion. That doesn't even make any sense. Okay? And then here's our population for these other two. Okay? And so again, we're increasing kind of in this general trend, right? So we would say positive association, right? If we were going to draw a trend line, again, my trend line here that I drew, not a good one. Why isn't that good? Well, guys, it's got to be a little bit closer to the data points, okay? Let me make a better one, right? So if this were it, I would say, bam. That's a pretty good one there. We have some criteria, okay? And I'm going to talk about it here on our next slide. For if you're a good trend line, you do certain things, okay? So here's my next table. Here it is. Awesome. It says draw a scatter plot. Bam, it did that for me. Yes. All right. Determine what relationship exists, if any, in the data. So guys, study this data. Here it is. I think this is going uphill, okay? So yes, I think this is positive association. Now it wants me to draw a line of best fit, and then it wants me to write the slope-intercept form of the equation. Woo! Okay, I'm going to zoom in on the graph for this part. So folks, if you are a good line of best fit, you do a couple things. right? Thing number one, we've already talked about. You've got to go in the direction of the association or the correlation. So this one is positive, so we need to be going, right, uphill, okay? Thing number two, it's okay to go through certain dots, right? By dots, guys, I'm talking about these, okay? It's not okay to have your line of best fit be all above or all below the dots, okay? So, roughly if we had half of our dots above our line and half below, that would be cool, all right? So, guys, I'm going to draw. So these are bad trend lines. Like, look, oh, it goes through a dot, but all my other dots are above the line. That doesn't work. Not very good. How about this one? Same thing, right? Opposite, really. All my dots goes through one here are below it, okay? What about this one? So maybe we start here. We do that. Okay, that's kind of getting better. I think that's a little too steep for where we are, all right? All right, what about this one? We kind of need a mix of those last two, all right? So again, we're just roughly trying to guesstimate, all right, these lines. So, if you look, guys, it looks like most of our data goes through here. Hey, Mr. Wessels. Hey. We're talking about scatter plots. You want to do this? Mr. Wessels does not want any part of scatter plots, guys. All right, guys, here we go. All right. How about that for a line of best fit? You guys good with that? You better be, because I am. All right, so there's my line. Again, doesn't go through any dots. That's okay. All right, but what it does do, right, is roughly, now again, I got 5 dots, folks. We couldn't evenly have half above and half below. All right, but I think this does a good job. So there we go. Pick 2 points. All right, this is hopefully where, all right, maybe you got to go back and redraw. You got to redraw your line because you didn't get 2 good points, right? But I think, look, mine were okay. So I'm going to use this point here, right? I'm also going to use this one over here. Okay? All righty. So here we go. So I'm going to use this point right here. This is 0, 10, 75. And this is, what is this? 8, 11, 75. Okay? Think back to what we did in 4-1, 4-2, and 4-3. Write me, well, really 4-1 and 4-2. Write me an equation. It wants it in slope-intercept form, right, for those 2 ordered pairs, for the line that goes through these 2 points. Can we do it? Mm-hmm. And here's what's even better. Do we know the y-intercept? We do, right? I just got lucky. 1075 was my number. Okay, so I really just need to find slope here, guys. Can't I then write my equation? Yeah, okay. So 1175, right? Minus 1075. 8 minus 0. Okay, thankfully I got a calculator here. Although Natalie never uses a calculator, let's be honest. All right, this is 100. Fine, I won't use it. Look, I'll put it behind my back. This is 8. I guess we could turn this into 50 over 4, which is 25 over 2, which is 12 and a half. Okay, either one of these are okay slopes. Look, I did all that without a calculator. Okay, there's our slope. So put it all together. Put it all together. So y equals mx plus b. So y equals my slope. Sure, I'll use 12.5. X plus b, my y-intercept, that's the 1075 number, okay? Why would I go to the trouble to do all this? Well, because, folks, now we can take this equation and now we can make predictions about the number of bachelor's degrees that are received in any year, right? And we can also make comparisons, right? Like, we're predicting, basically, hey, in this year 6, we think there should be this many bachelor's degree given out, but really there was more. I wonder what caused that, okay? Anyway, so that's what we're going to kind of do with this. I think, do I need to do something with this equation now? I think I do, don't I? Let me write the slope-intercept form for the line of fit. Okay, we did that. And that's all I got to do. Sweet. Okay. Look, guys, I know I'm a little long-winded. There's a lot of stuff going on here, and it's a little bit confusing, right, if you're not in class, because then it's kind of tough, right? It's kind of tough. Hey, this is our question from earlier. Sweet. The table and graph show the growth of the world population. Use this equation to predict the world's population in 2025. That's coming up here in just a couple years. Okay? All right. Alrighty. So, sure, we can do this. You guys think we can do this? Yeah, why not? Okay. Okay, X, Y. So I want to replace 2025. Is that an X value or a Y value? Well, clearly it's an X value, right? So we are going to replace X, right, with that number, okay? And then we should predict that equation. Look, we could use our graph. If this is the year 2100, I don't know, maybe 2025 is like here. I don't know. I mean, somewhere over 7,000. Remember, this is in millions, right? Which really is 7 billion. Okay? Anyway, whatever. Let's go, people. Replace X with that number there. So it's going to look like this. The population Y is equal to this random 35.1 times the year 2025 minus this 63,870. Okay? Now, this I do need a calculator for. All right? So we're going to multiply those two together. Then we're going to subtract it from that 63,870 number. Okay? Again, when you guys do this, just make sure you're taking your time. Don't try to type everything in crazy fast. So minus 63,870. Here is what I get. I get Y equals 7207.5. Okay, remember, this is our population in millions. So this would be like 7,207,500,000. Okay, again, this is why we do this, guys. We make scatter plots with data that we have, and then we can predict stuff, right? We could have predicted what the population should have been or what our model predicts it to be, or we can do cool stuff like, hey, I wonder what it'll be in the future, okay? Remember, in the future, that's extrapolation. If it's in our data, interpolation, okay? I'm sure you could ask Kane or Kreitzer about roots and, inter and extra, and they could give you all kinds of, it's got to be in and out, I would assume. I don't really know. Okay. Alrighty. Here we go. This looks familiar. We just did this one a little bit ago. Now look, we came up with a different equation here, but that's all right. Their line of best fit was a little bit taller than ours. Okay, and that's why these aren't very good. Gosh, wouldn't it be great if there was something that was better? Because look, isn't my line of best fit probably going to be a little bit different than the one that you draw, which might be a little bit different than the one that he draws or the one that she draws? So there's got to be a better way. Don't you worry. It's called 4-6, all right? But for now, we're going to pretend that doesn't exist, okay? And we're going to do it this way. All right, so again, here we go. We've got to figure out, or we got to use this equation to predict the number of bachelor's degrees that will be received in 2015. Okay. All right, so be a good reader, guys. Years since 1988. Unlike the last question where we just threw the year, 2025, right in for our X. They don't want us to do that because it says years since. So I need to know what X value represents 2015. Years since 1998. If you don't know, just subtract the years, guys, right? Literally, it's nothing more than taking 2015 minus 1988. Yes, I know. Natalie's grabbing her calculator and she's typing this in. That's fine. That's okay. I want you to get 27. I don't really care how you do it, okay? But 27 is the X value that we're going to throw into this equation here. Y equals 8X plus 1104. Okay? So replace X, again, that's a year, right, with 27. And then that will give us how many bachelor's degrees will be received. Again, those are in thousands. Handy dandy calculator. I mean, I could try to do all that in my brain, but let's be honest, folks, it's a little late in the day. Okay? I get 1,320. Okay? Remember, this is in thousands. Okay? This is in thousands. So you can add 3 more zeros onto that and call it 1,320,000. Okay? There you go. That's it. So guys, I know a lot of new words. I know this video was long. Thanks for sticking with it till the end. Again, things to remember are 3 different kinds of association. Those aren't going to go away, right? Line of best fit. I know it seems a little confusing, but it's really not, right? We're just picking out points, right, on our graph, well, really on our line of fit, and then writing that equation, okay? And again, we've replaced values before in a function or in an equation, and they give us another value. So we've done a lot of this, just not, it hasn't looked like this, okay? If you got questions, let me know. If not, have a great day. I'll see you soon.